Demystifying Neural Networks, a beginner's guide to the brain. Hey there! Have you ever wondered how the brain works? It's a fascinating, complex network of interconnected cells that enable us to think, learn, and experience the world around us. But have you heard about neural networks and their striking resemblance to our brains? Before we begin, please subscribe to stay updated on content similar to this video. Now, let's get back to our topic. Imagine your brain as a highly sophisticated computer. It's made up of billions of cells called neurons, much like tiny switches that transmit and process information. These neurons communicate with each other through electrical and chemical signals, forming an intricate web of connections. Now, think of a neural network in the realm of artificial intelligence as a simplified model inspired by the brain's structure and function. At its core, a neural network is composed of layers: input, hidden, and output layers resembling the brain's neurons, synapses, and networks. The input layer receives information, which is then processed through the hidden layers, and the output layers provides the final result. Each layer contains nodes that perform specific tasks, akin to neurons processing and transmitting information. Let's take a look at a simple example to grasp this better. Imagine you're teaching a neural network to distinguish between images of cats and dogs. You'd feed the network a bunch of labeled images, some with cats and others with dogs. The input layer receives these images, and the hidden layers work on processing the features, like fur patterns, shapes, or ear positions. The output layer then predicts whether the image contains a cat or a dog. Through multiple iterations, the network learns and improves its accuracy by adjusting its parameters, much like how our brain learns from experience. One of the remarkable things about neural networks is their ability to learn from data. This process, known as machine learning, involves training the network by exposing it to vast amounts of data, allowing it to recognize patterns and make predictions without being explicitly programmed. This learning is often facilitated by algorithms, such as backpropagation, which adjust the network's parameters to minimize errors and enhance its performance. But just like our brains, neural networks aren't infallible. They can also make mistakes, especially when dealing with ambiguous or unfamiliar data. They rely heavily on the quality and quantity of data they're trained on. This emphasizes the importance of diverse and well-curated datasets to ensure more accurate predictions. The applications of neural networks are widespread and diverse, from recognizing speech in virtual assistants like Siri and Alexa, to enabling self-driving cars to perceive and respond to their environments. These networks are powering incredible advancements in various fields. They use in healthcare for diagnosing diseases from medical images, in finance for fraud detection, and in countless other areas where pattern recognition and prediction are crucial. Now, you might wonder, how do we improve these networks? Just like exercising your brain keeps it sharp, neural networks can be fine-tuned and optimized. Researchers and developers constantly work on enhancing network architectures, creating more efficient algorithms, and devising strategies to make these networks faster and more accurate. While neural networks have made significant strides, there's still a lot to explore and improve. One of the challenges is the black box nature of some networks, meaning it's not always clear how they arrive at their decisions. Researchers are striving to make these systems more transparent and interpretable, ensuring trust and understanding behind their workings. Neural networks, much like the brain, showcase an amazing capability for parallel processing. Just as the brain handles numerous tasks simultaneously, these networks perform operations across their layers concurrently, enabling them to process vast amounts of data in parallel. This parallel processing is a key factor in the efficiency and speed at which neural networks operate, mirroring the brain's ability to handle multiple thoughts and functions at once. Delving deeper, let's look at the concept of deep learning. This term refers to the use of neural networks with multiple hidden layers, allowing these networks to create more abstract representations of the input data. The layers in a deep neural network progressively extract higher-level features from the input. For instance, In image recognition, the initial layers might detect edges and basic shapes, while deeper layers might identify complex patterns like facial features or objects. This process reflects the brain's hierarchical organization, where sensory input undergoes multiple levels of processing in different brain regions, ultimately leading to complex perceptions and understandings. Moreover, the adaptability of neural networks, referred to as their plasticity, is another parallel to the brain's ability to rewire and reorganize itself based on experience. Neural networks can undergo what's called transfer learning. Once trained on one task, they can apply their learned knowledge to another related task, much like how our brains repurpose learned skills and knowledge from one context to another. The evolution of neural networks has also given rise to specialized architectures like convolutional neural networks or CNNs and recurrent neural networks or RNNs, each tailored specific tasks. CNNs excel in tasks involving grid-like data such as images, leveraging shared weights to recognize patterns irrespective of their location within the image. RNNs, on the other hand, are designed for sequential data, making them perfect for time series analysis or natural language processing, as they maintain a memory of past inputs to better understand and predict subsequent information. Furthermore, the concept of unsupervised learning in neural network is reminiscent of the brain's ability to find patterns in data without explicit labels. This form of learning allows networks to recognize hidden structures or regularities within the data itself, much like how our brains can recognize commonalities or anomalies in information without specific guidance or instructions. Ethical considerations surrounding neural networks continue to be a focal point. Issues related to bias in algorithms, data privacy, and the potential impact of AI on employment are ongoing debates. Ensuring these systems are developed and used responsibly is critical. Efforts are being made to establish ethical guidelines and frameworks for the design and deployment of AI to ensure fairness, transparency, and accountability in their use. In the quest for more advanced and efficient neural networks, researchers are exploring new frontiers, such as neuromorphic computing, seeking to create systems that not only emulate the brain's structure and function, but also its energy efficiency and adaptability. Such endeavors aim to push the boundaries of AI capabilities, potentially leading to breakthroughs in various fields, from healthcare to environmental sciences. As we journey further into the potential of neural networks and AI, the collaboration between human intelligence and artificial intelligence becomes increasingly significant. These technologies are tools to augment human capabilities, providing us with insights, assistance, and solutions to challenges we face in an ever-evolving world. Understanding the link between neural networks and the human brain offers a fascinating perspective, opening a window into the incredible potential of artificial intelligence. It also prompts us to ponder the ethical, societal, and philosophical implications of these technologies. So, next time you hear about neural networks or witness AI-powered technologies in action, you'll have a better grasp of the magic happening behind the scenes, reminiscent of the incredible and awe-inspiring functionality of our own remarkable brains. If you've found this information informative and thought-provoking, I would be immensely grateful for your support. Please consider giving this video a thumbs up and subscribing to my channel. Thank you for joining me on this journey, and I'm excited to share more insights with you in the future. Until next time!